presentation is about supporting math achievement with science tasks at Kennedy Junior High School in Lisle, Illinois. Though Kennedy Junior High is in Lisle, it is part of the Naperville Community Unit School District 203. Like all schools in District 203, Kennedy is required to have a school improvement plan, also known as a SIP. The SIP includes student growth goals in mathematics and English language arts, also known as ELA, achievement. The SIP might also include goals for school climate or teacher practices. In Illinois, according to the Illinois State Board of Education, the Illinois Assessment of Readiness, also known as the IAR, is the state assessment and accountability measure for Illinois students enrolled in a public school district. Because of this, the SIP measures student achievement in ELA and math with the IAR test. This presentation focuses on math achievement, so I will read aloud the math goal for the 2021-2022 school year. By spring of 2022, the goal was that 80% of students will meet or exceed on the mathematics section of the IAR. This means that the expectation for Kennedy students during the past school year was that at least 80% of them would have met or exceeded their grade level expectations as measured by the IAR. This is clearly a growth goal when we look at the performance data for IAR and math. The School Improvement Committee decided to focus on the 2019 IAR test in order to set its growth goal for the past school year. It disregarded the 2021 and 2020 data on account of the COVID-19 pandemic. In 2020, no students at Kennedy took the IAR, and in 2021, because of the pandemic, there just weren't enough students who were attending Kennedy in person for the data on the IAR to be meaningful. So in 2019, we can look at the dark green area on this graph and the light green area. The light green area says 42.4 and the dark green area says 32. By adding these together, we get 74.4. This means that at the end of the 2018-2019 school year, 74.4% of students met or exceeded the grade level expectations for math on the IAR test. So by having a goal of at least 80% of students meeting or exceeding their grade level expectations on the IAR, we clearly have a growth goal. So during the year, the students take another test called the MAP test. MAP stands for Measurement of Academic Progress. This is a progress monitoring test, and various educators will look at MAP data throughout the year for different purposes. The SIP committee reviews the MAP data to see if the students are on track to meeting the SIP goal on the IAR test. So when we look at the MAP math data, these are measurements of percent above the 80th percentile. At first, it could look alarming because we know that we've got this goal of at least 80% of the students meeting or exceeding grade level expectations for math on the IAR, and then we see numbers like 57.4% or 65.5%, and it might seem that we are way off from meeting that SIP goal. However, we have to sort of compare apples to oranges, and that means relate the MAP data to the IAR data. This is kind of like taking an SAT score and converting it to an ACT score. So when we look at this, if we see that at least 50% of students are above the 80th percentile on the MAP test, this means that at least 50% of the students are on track to meeting their individualized growth goal that the MAP test puts out for them. And this would also mean that at least 80% of the students at Kennedy are going to meet or exceed the grade level expectations on the IAR. So when we look at, for example, the grade 6 data, and we see winter 2022, 58.1%, this means that 58.1% of the sixth graders in winter 2022 were on track to meeting their individualized growth goal put out by the MAP. The MAP is a computer adaptive test that gives an individualized growth goal or target for each student. For the seventh graders, 58.3% were on track to meeting their individualized growth goal. And for the eighth graders, 61.1% of the students were on track to meeting their individualized growth goal. All of this means that as a whole student body, at least 80% of the students at Kennedy were on track to meeting or exceeding the grade level expectations on their spring IAR test. However, when we break apart the data, we see achievement gaps. When we look at the data for fall 2019, fall 2021, and winter 2022, we see constant achievement gaps between females and males. The achievement gap is about 10% or so. And the males are consistently outperforming the females on the MAP test. At the February 2022 School Improvement Committee meeting, the math interventionist said that these achievement gaps are recurring. They occur every year. We also see other achievement gaps between racial subgroups. We have on this graph students who identify as Asian, students who identify as Black, African American, students identifying as Hispanic, Latinx, students identifying as two or more races, and student identifying as white. When we look at this, we see that it's only the Asian students, only 50% or more of the Asian students and 50% or more of students identifying as two or more races who are on track to being or meeting their individualized growth goals put out by the MAP test. So this is a big deal that we've got all of these achievement gaps between the racial subgroups. We also have significant achievement gaps with other subgroups. We see that when we look at students who are identified as economically disadvantaged, students who are receiving special education services, and students who are English language learners, we see that for none of these subgroups do we have at least 50% of the students on track to meeting their individualized growth goals put out by the MAP. So at Kennedy, we don't just ignore these achievement gaps, we use the response to intervention instructional system. And the way response to intervention works, according to the RTI Action Network, there are 3 tiers. At Tier 1, we focus on the general education classroom. All of the teachers, this means all of the math teachers at Kennedy, are expected to use the Danielson framework to guide their teaching practices. And so this means that they are providing that high quality research-based instruction that is demanded for a tier 1 level of instruction. Also, the classroom teacher, the math interventionist, or the math teaching assistant will take aside small groups of students in the gen ed classroom for reteaching. Now, we'll get into Tier 2. This is the general education classroom plus an additional intervention class. So all of the students continue receiving high quality instruction in the general education classroom. This is according to the RTI Action Network, which Kennedy follows. But in addition, based on the MAP data, also based on ongoing assessment data, such as teacher-made formative assessments like quizzes, the math interventionist is going to identify select students who really need an additional math class. So those students are going to attend the gen ed math class, and during the 9th period supervised study, they're going to also spend time in an additional math class with the math interventionist. Then for tier 3, this is in addition to receiving high quality instruction in the gen ed classroom. A probably even smaller group of identified students are going to be receiving intensive individualized instruction during a different class period. And if students aren't responding to that individualized instruction, then they start getting evaluated for an individualized education plan, also known as an IEP. So the RTI instructional system is effective, it's research-based. However, it's not perfect. So to continue to increase math achievement and to narrow those achievement gaps, there is this opportunity to integrate math into science. There was a small study done in 2003 by 2 researchers, Judson and Sawada, and it was a study of 53 eighth graders at a junior high in Arizona. And in this study, students who were applying the statistical methods they were learning in their math class, when those students also applied those methods to science tasks, um, the data showed that the students performed better on their end of unit statistics test in math, significantly better. 11 of the 27 students in the experimental group earned A's, whereas only 4 of the 26 students in the control group earned A's. Also, no students in the experimental group earned F's, and 7 of the 26 students in the control group earned F's. So this study was done in 2000. That is a long time ago, but we also want to point out that there isn't a lot of research in this area. So it seems like integrating math into science to boost math achievement is just sort of a marginalized or forgotten about area. That is, the science classes might be an untapped area to support math achievement. So what can this look like? Well, in 6th grade, the students analyze water quality. And a way to do this, they do a simulation assignment where they take, you could say, fake water samples. And those water samples have pollution sensitive macroinvertebrates or water bugs and pollution insensitive macroinvertebrates. And they're calculating the ratios of pollution sensitive macroinvertebrates and pollution insensitive macroinvertebrates in those water samples in order to detect water quality. And the students in science or in math class throughout 6th grade are learning about proportions and ratios and percentages. So this is an opportunity for the 6th grade science teacher to consult with the 6th grade math teacher to learn what kind of math vocabulary, what kind of procedure, what should the math work look like in the science class in order for the students to really apply those math skills in the science classroom. So there was a year where a 6th grade science teacher who had previously taught math knew to do this. She thought to do this, whereas the other 6th grade science teacher had not taught math and didn't think to have this integration. So that science teacher just gave the students a shortcut method, said calculate this, and this is how you get your numbers. And that other science teacher had unknowingly just thrown away an opportunity for the students to apply their math skills in science. So possibly, if the science teachers take a really close look at their curriculum and look for those math application opportunities, they could meet with their same grade level math teachers and learn how they really can maximize some math instruction in science. So this is the action plan. During first trimester, the science teachers will really closely study their curriculum for second trimester to identify math application opportunities. It's possible that maybe just one opportunity is found, or maybe no opportunities are found. This is because the math department coordinator at Kennedy did point out that when Kennedy transitioned to the next generation science standards, there was no longer as much overlap between math and science as there had been in the past. But also, the science teachers have never really analyzed their curriculums for math application opportunities. So there could be some hidden opportunities in there. If they can't find a math application opportunity, then they should consult with the science department coordinator, and maybe she would be able to find one. Then the science teachers should attend at least one same grade level PLC meeting to receive guidance from their math colleagues regarding vocabulary and procedures. Um, and if the science teachers were not able to find a math application opportunity in their curriculum for second trimester, then they should still attend at least one math PLC meeting in order to hear about common areas of struggle for the students. And perhaps just by listening to that conversation and talking to the science teachers, they'll get some ideas on how they could support math instruction in science. Maybe doing something with data analysis, for example. But if the science teachers do find those math application opportunities, then they can consult with their same grade level math teacher colleagues, and that math teacher can give them some guidance on how to set up a math problem, or how to talk about the data being represented on a graph, maybe bringing slope and rise over run into the conversation. So we never know what we can find until we start looking for things. And so then during second trimester, in their weekly PLC meetings, the science teachers can design the math application tasks and common formative assessments for these tasks. And then they can actually teach these lessons, collect the formative assessment data, and with their colleagues in their PLC meetings, they can analyze that data, and they can see if they could improve their instructional practices or identify students for reteaching and reassessment opportunities. This goes along with the best practices for PLCs as determined by DeFore et al. 2008. And then also during second trimester, the science teachers should carefully study or peruse their curriculum for third trimester to identify those math application opportunities. And they're repeating the work that they did during first trimester. They'll look for math application opportunities for third trimester, then they'll attend at least one math PLC to discuss how to leverage those opportunities in the science classroom. And then they'll do the same type of work in their weekly PLC meetings. So they'll design the math application tasks, those common formative assessments. They'll actually teach these lessons, collect the formative assessment data, and then analyze that data in their PLC meetings. Now, moving into third trimester, the science teachers can peruse their curriculum for first trimester next year to identify math application opportunities. And they should also attend at least one math PLC to discuss how to leverage that opportunity in science, or those opportunities. There might be more than one. And then once again, in their weekly PLC meetings, they should design the math application tasks and common formative assessments for these tasks. Additionally, the SIP committee will analyze the winter 2023 and spring 2023 math data. And the science department coordinator and at least one representative science teacher will attend these data analysis meetings to clarify the work that's being done in the science classes to leverage math opportunities. And the committee will discuss and reflect on how, if at all, these math integrations in science have impacted science achievement. Also, at the monthly science department meetings, the science teachers will be invited to give short presentations, maybe 5 to 7 minutes, on how they are integrating math into science. And it's highly encouraged for them to bring in student work samples and to share formative assessment results. So then, when that data is ready for analysis, that spring 2023 IAR data, the SIP committee will analyze the spring 2023 IAR math achievement data during the early fall of the next school year to discuss the impact of integrating math applications into science. And the big questions would be, should the Kennedy science teachers continue with these deliberate integrations? And how should, if they should continue to do this, how should the action plan from the previous school year be adjusted for this new school year? Thank you for listening to this presentation on how to support math achievement in science class at Kennedy Junior High.